Good morning.
Morning.
When it comes to food packaging, how does refrigeration help with efficiency?
Unfortunately, we're a really big energy user. Approximately 30% of all the power generated in the UK goes to driving the refrigeration process. And if you look at the food sector, food, beverage, dairy, they're basically all produced inside a massive refrigerator. So the whole factory, in effect, is a refrigerator, and anything that goes on in there generates warmth, and heat is energy. So, for instance, if product goes in at ground temperature, so you bring vegetables in, the first thing you do, you cook them, and then you need to bring them back down to refrigeration temperatures in a great big refrigerator. So we have to remove that energy, and that takes power. If you're looking at the food sector, if you're a dairy, if you're a brewery, approximately 50% of your energy is driving a refrigeration process. If you're producing poultry, it's 70%. If you're storing food, we're 80-90% of the power. So it's a really big power consumer.
We hear about heat pump technology. How easy is it to apply that to the process?
Relatively simple, actually, because everybody's got a heat pump. You know, you've got one at home. You go to the supermarket, you buy refrigerated goods, it heats up as you're going home. You then take it home, put it in the refrigerator, and the heat is taken out of the product, and it's basically that heat is rejected at a warm temperature out the back of the fridge. So it goes to heating up the kitchen. So if you take that on an industrial scale, the way a heat pump works is it just takes all that energy that actually you took out the product in the first time or out the factory, and rather than dumping it outside into the ambient air at 30 degrees, it just boosts it up to a temperature which you can put back into the process. So if you took your process and rather than making the heat by burning a fossil fuel, and you recovered the heat via your refrigeration cycle, it enabled you to switch the boiler off. So to give an example, if you know, this is by no means a large figure, so if we said 1,000 kilowatts worth of heat generated through a traditional boiler, you have to burn about 1,200 kilowatts worth of gas or fuel. If you burn natural gas at a rate of 1,200 kilowatts, that costs you around about £25 an hour, and it generates 250 kilograms of CO2 an hour. Instead of doing that, if you applied a heat pump and recovered the heat, it would only cost you around 70 kilowatts of electricity rather than 1,200 kilowatts worth of burnt gas, and it would only generate around 20 kilograms of CO2. So you've reduced your cost by about 2/3, and the climate emissions, your CO2 emissions, by 90%. So it's a total recycle of heat.
Heat pumps effectively are a win-win situation. Now, I know there's different types. So what is it, for example, about the ammonia-based heat pumps? What makes them stand out?
Yeah, ammonia is just the best refrigerant thermally. Yeah, so there's no question about that. There are some issues with its use. You have to be careful how you use it, but that was designed out years ago. And if we look back in history, ammonia, natural refrigerants we call them, natural refrigerants were used initially, and then we started changing over to synthetic refrigerants, so man-made refrigerants, which we then found out were bad for the environment. So there's legislation driving the change to move back to natural refrigerants. All these food manufacturers, the dairies, the breweries, who would typically these days possibly have a synthetic refrigerant, they're having to change back to ammonia anyway. You've got to change your refrigeration system anyway. Adding a heat pump just gives you a return on investment. So if you go and spend, I don't know, £1 million on a new refrigeration system, if you spent £1.1 million, that then allows you to switch the boiler off. All of a sudden, you know, you've got a return on investment on your capital cost. It is a win-win. There is no downside to it.
Given the fact that it's a win-win situation, you know, why is it only just becoming topical now?
Refrigeration is seen as an add-on. It's not seen as an integral part of the process. So our process guys go in a year before we get invited to the party normally. And in that time, the client's already decided, I'm going to buy a boiler, I'm going to buy all my process equipment. And they said, oh, I need a refrigeration plant a year down the line. So where it's changed is our process guys are now talking talking about, actually, you don't need a boiler. We can do this with the waste energy from the refrigeration plant via a heat pump. And the technology's just moved on. It's massive in district heating. You know, we're putting district heating loops all around our cities in the UK now. It's been in Scandinavia for years, but those temperature levels have been quite low. The technology's developed in the fact that we can now achieve much hotter temperatures efficiently, which means that we can now cook stuff. So we can cook vegetables and fruit and meat. So it's back into the process. We're taking an innovation that was used for district heating and we've boosted it up to allow us to put it into food and beverage production. So
technology is the answer in so many different areas, and it's really interesting to see how it's helping with refrigeration and also to make that process more economical and more efficient. It's been great finding out more. Robert Unsworth from GEA, thank you very much indeed.
Thank you.